Hey, Mr. Aridum here, trying a new video with a new beard. Awesome. Here we go. We're going to do some determining of solubility of covalent solutes and covalent compounds. So, first thing is we have to know is for covalent compounds, the rule is likes dissolve likes. What this means is polar will dissolve in polar, and nonpolar will dissolve in nonpolar. Polar and nonpolar will not mix. So what we have to do here is we have to draw the Lewis dot structures for each one of these. So starting off with example A here, we got water, H2O. Hopefully we understand it has 8 valence electrons. So we have an O bonded to an H, that's 2. Bonded to an H, that's 4. 6, 8. Remember, if it has lone pairs on the central atom, it is polar. Polar. Okay. And now we're going to do phosphorus tribromide, which is PBr3. Phosphorus has 5, bromine has 21, so we're going to do 26 dots here. So we have a P in the center. Br, Br, Br. 12, 14, 16, 18, 20, 22, 24, 26. Again, we have dots on the center atom. So this is polar. So these will mix, because polar dissolves in polar. Okay. Now I'll try not to lean on the table so it doesn't flash as much. Okay, ammonia Nh3. So Nh3, this has 8 valence electrons. N, H, 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 and a pair of dots. Pair of dots on the central atom makes this polar. And then we have methane. Hopefully you remember methane is CH4. C bonded to H, bonded to H, bonded to H, bonded to H. This is nonpolar, because this has 8 valence electrons. So these don't mix, because polar does not mix with nonpolar. Hydrogen gas, hopefully you remember, hydrogen gas is H2, and it's just an H bonded to an H. Those are equal. So this is nonpolar. And then we have chlorine gas, Cl2. This should have 14 valence electrons. Chlorine bonded to a chlorine, and then dots around the chlorine like this. Cl and Cl, this is equal, so that is also nonpolar. Don't mix. No, they do mix, Mr. Aridum. Come on, it's nonpolar and nonpolar. Come on, Mr. Aridum. Since they are similar. Hey, did I tell you water's polar? And then we're going to do carbon tetrafluoride, which is CF4. C, and we're going to do 32 of valence electrons. C bonded to an F, bonded to an F, bonded to an F, bonded to an F. There are going to be no dots on the central atom for this one. So this is non-polar. So these don't mix. And finally, ethane. C2H6, C bonded to C, H, 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 H. That's 12 electrons. So we're good there. Actually, it's 14, isn't it? 8 plus, yeah, it's 14, Mr. Aridum, come on. C3H8 is propane. C, 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 12 and 8. So we did 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, figuring out if these are polar or non-polar. There's no dots on the central atom in ethane, so that is non-polar. There's no dots on the central atom here either, non-polar. Your alkanes are non-polar. So neither one of these mix. No, they do mix. Because they're both non-polar. Hopefully I didn't confuse you too much. Remember, polar and polar mix. Non-polar and non-polar mix. But if they're opposite, polar and non-polar, they don't mix. You guys are champions. The legend is out.